go ahead and have out your notebook because we're going to be taking notes today. There's going to be notes and then there's a check for understanding for you to watch after you've done this. So we're taking notes, and the title for the notes today is going to be Types of Numbers, which sounds like a weird title, but I'll explain what I mean in a second. So go ahead and title your notes and then put it in your table of contents. And to illustrate why it is that we need to take notes on types of numbers, I want to consider something. So I'm going to imagine you've got a person here who walks 5 meters forward and then walks 3 meters backwards. And then I could ask you, how far did this person travel, right? There's probably two answers that you could give. You could either say that this person traveled 8 meters, right, because they went 5 plus 3, or you could just say he traveled 2 meters because he ended up 2 meters from where he started. Okay? I'm going to give you another example, right? So same sort of thing, but this time the guy does the opposite, right? He starts here, he goes 3 meters forward, and then he goes 5 meters back. Well, how far would you say he went this time? Again, you might still say he went 8 meters, or you might say he went 2 meters, but we have to say he went 2 meters backwards, so how are we going to do that? We're going to do that by saying he went negative 2 meters. Okay? So these are, so basically when I ask the question, how far did somebody travel, there's two valid answers, right? And so we need a way to keep those two things separate. And it turns out the way we're going to do it is we are going to always talk about the total amount that you travel. We're always going to talk about that as the distance. So if you say, in physics, we're going to refer to this answer, the question of how far you went. We're going to refer to that as the distance. And this answer, the question of how far you went, we are going to refer to using the word displacement. Okay. Now, we're going to find there's going to be a lot of cases in this class where you're going to find that things, there's certain times where we're going to want one answer, and there are other times where we're going to want a different answer. And so we, in general, have to refer to two different types of numbers in physics. And those two different types of numbers we're going to refer to as scalars and vectors. Now, scalars are numbers like you're used to seeing, right? So 3 meters, 5 meters, 8 meters. Those are examples of scalars. Scalars are going to be a number that have magnitude only, as opposed to vectors that are going to be a number that have magnitude and direction.
Hey. I'm applying for a new film loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah!
So after that, again, you should probably never forget the difference between scalars and vectors. Vectors, again, have both magnitude and direction. Now, in physics, how do we indicate direction? Well, you've kind of already seen it here, right? What's the difference between this guy and this guy? This guy ended up 2 meters ahead of where he started. This guy ended up 2 meters behind where he started. So in physics, we're going to indicate direction by using positive or negative. So we're going to say vectors can be positive or negative. And if they're positive, it's going to mean that they're going forward, or eventually might mean up. Negative is going to be backwards. And scalars are always going to be positive numbers because they do not have direction. All right. So of the things that we've written down here, right, distance is an example of a scalar, because distance, in both these cases, right, the distance, it didn't tell you which way he went. It didn't tell you whether he went in the forward or the backward direction. It just told him how many steps did he take, or how many meters did he walk. So distance is a scalar, whereas displacement is going to be a vector. Now, you may remember from the last, we did the Nearpod thing last class, or depending on when you're watching this, we did the Nearpod thing as our last e-learning assignment. And remember, we talked about speed and velocity. What was the difference? Remember, velocity included direction. So we're going to refer to velocity as a vector, and speed we're going to refer to as a scalar. If you recall, acceleration was a vector because it was change in velocity, which was speed and direction. So acceleration is a vector. There is no scalar form of acceleration. Something that doesn't have a direction would be like time. So if you try and time how long something takes, it's not that it goes 3 seconds forward or 3 seconds up or 3 seconds backwards. It's just a magnitude, right? So time is a scalar. There is no vector form of time. So here are some examples of scalars and vectors. All right. So I'd like to just say one more thing about the difference between scalars and vectors here. And I want to think about it in terms of acceleration, right? So I want to imagine 3 different cases of cars. And I want to think about their motion and the velocity and acceleration vectors of their motion. So again, scalar is something that has only magnitude. Vectors have magnitude and direction. So when I'm talking about the velocity and acceleration of a car, I'm talking about a vector, which means they have to have magnitude and direction, right? So for example, if I have a car, I can say that the car has a positive velocity, and I could say that it has a negative acceleration. But I want you to get in the habit of thinking about what that means. Positive velocity, what positive just means is it means that the vector is pointing forward. Negative acceleration, all that means is that it's pointing backwards. So if you've got something that has a positive velocity and negative acceleration, what do you think it's doing? Well, it turns out the velocity vector always tells us which way we're going. So this would be a case of a car going forward. And if you're going forward, but you've got an acceleration that's fighting against you, we're going to say that that means that you're slowing down. And that kind of makes sense, right? You probably would have thought that negative acceleration would mean slowing down. But I want to refer to something else. Let's say instead we had a car that was, I guess this car was going forward, right? Let's say we had a car going backwards, right? We would say that that car has a negative velocity. And let's go ahead and give this car a positive acceleration. By the way, I did something and I didn't explain it. Notice that I draw my velocity vectors. I draw it with one line, and I draw my acceleration vectors with 2 lines. It's just how I keep them straight in my mind. So velocity vectors I draw with 1 line, acceleration vectors with 2 lines. So again, this car has a negative velocity, but it's got a positive acceleration. What does that mean? What is this car doing? Well, I'm going to say this car is going backward. Why is it going backward? It's going backward because it's got a negative velocity. It goes backward, but in this case, even though it has a positive acceleration, I'm going to say that it's slowing down. Why is it slowing down? It's slowing down because the acceleration is fighting against the velocity. So positive acceleration doesn't only mean that you're speeding up. Positive acceleration tells me that its direction is forward. Negative velocity tells me that the velocity's direction is backward. And if they're going in opposite directions, we say that they're slowing down. So I'm going to give you one more example, right? Here's another car that I'm going to say has negative velocity. And I'm going to say it also has negative acceleration. What do you think that car is doing? Well, I'm going to say that that car is going backward. Why is it going backward? Because you always look at velocity to figure out which way it's going. This car is going backward because it has a negative acceleration. But I'm going to say it's going backward, and in this case it's speeding up. Even though it has a negative acceleration, it's speeding up because acceleration and velocity are the same direction. One way to think about this is if you've ever played Mario Kart, right? You know when you're playing Mario Kart and you push the button to brake, what happens when you brake and then you stop, right? Then all of a sudden you start going backwards. So one way of thinking about that is pressing the brake button is giving you a negative acceleration. While you're going forward, the negative acceleration slows you down, and then when you start going backwards, the negative acceleration speeds you up. All right, so those are the notes for today. Go ahead and answer the Check for Understanding questions, and I will see you in class soon.